Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman. I will present to you machine condition monitoring and fault diagnosis for assignment variation analysis and monitoring BMMM 3583. Here are the list of presenter. Introduction. In engineering, maintenance accounts for a half of processing and manufacturing costs. Planning a maintenance activity helps maximize resource use. Condition monitoring and fault diagnosis improve product qualities. It's a process monitoring tool because it helps maintain optimal machine operation. Machine condition analysis use various data types: vibration, lubricant, oil grease quality, contamination, wear particles monitoring and analysis, force, sound, temperature, output, machine performance, product qualities, odor and visual inspections. The data will help determine the current conditions, trends, expected time to failure at a given load, types of fault that cause failure. This determines a machine health. Definition: machine condition monitoring and fault diagnostic is the process of observing physical parameters associated with machinery operation to determine machine health. Once a machine health is estimated, it can be used for many things. Condition monitoring monitors electromechanical system parameters. Monitoring parameter change and analyzing the physical relationship between parameters and faults enables time fault diagnosis and prediction. Loading and maintenance are two tasks directly related to the information. Machine condition monitoring and fault diagnostic are important engineering tools thanks to research.
Hello and Assalamualaikum. Today I will be present advantages of machine condition monitoring and fault diagnosis. First one is increase machine availability and reliability. Next is improve operating efficiency, improve risk management, which will be less downtime, reduce maintenance costs, reduce spare part inventories, improve safety, improve knowledge of the machine condition, which save short-term overloading of machine possible, extend operational life of the machine, improve customer relation, which less planning and unplanned downtime, eliminate of chronic failure, root cause analysis and redesign. And lastly is reduction of post-overhaul failure due to improperly performed maintenance or reassembly. Next is disadvantages of machine conditioning, monitoring and fault diagnosis. The first one is operational cost for running the program will be increased. Skilled personnel needed. Strong management commit needed. A significant run in time to collect machine history and trend is usually needed. And reduced costs are usually harder to sell to management as benefit when compared with increased profit. The next slide will be machine conditional monitoring and fault diagnostic case study CMFD. A successful machine condition monitor and fault diagnostic program defect, diagnose, prognosticates and prescribe. Next is detection require data collection, comparison to standard in-plan equipment limits and trending over time. Next is diagnosis involve recognizing fault types, which is different fault type may be serious and require different action, and determining fault severity. Next is prognosis involve estimating the time to failure, trending equipment condition and planning maintenance. Post-mortem analysis involve research in the lab and or field and system modeling. The last one is prescription. Is a condition monitoring and diagnostic activity dictated by collecting data. It may recommended changing operating condition, monitoring strategy, which is frequency or type, or process, or equipment design.
Assalamualaikum, my name is Muhammad KHUZAIRI bin MAZLAN, the third presenter of this group. Okay, next we go to the case study about wind turbine. Wind turbine are a complex and highly coupled power conversion system from wind energy to mechanical energy to electrical energy. To obtain a maximum wind energy and ensure safe and stable operation of wind turbine, many sensor and auxiliary equipment are installed in the nacelle of wind turbine. As we can see in figure 1, double feed induction generator on the left and permanent magnet synchronous generator on the right side. Next, the component of wind turbine can be divided into 3 subsets. First, wind energy subset, second, mechanical energy subset, and the last one, electrical energy subset. According to the energy flow, these devices are all a subset of the wind energy in the energy flow. Both the shaft and the gearbox are mechanical drivetrain in the nacelle, which belong to the subset of the mechanical energy. Since the vibration sensor is easily attached to the surface of the mechanical drivetrain, the vibration signal is generally preferred in the industry for fault diagnosis. Next, we go through to the fault detection in shaft. Shaft is the connecting device between the hub, the gearbox, and the generator, which play the function of energy flow transmission. The shaft constantly collide and rub against various components during the journey of sharing energy. The change of wind speed causes the rotation speed of the shaft to follow the change, which lead to a large fluctuation of force in the transmission process and greatly increase failure rate. By using the characteristic parameter corresponding to the fault in vibration and acoustic emission, the fault condition of the shaft is detected. When the shaft is in balance, the load torque of the generator will fluctuate periodically. However, it should be noted that the load of the motor is greatly affected by the fluctuation of wind speed, and the diagnosis results are greatly affected by the working condition. Next, we go through to the vibration signal. Vibration signal is the most widely used CMFD signal. Vibration-based CMFD technique have become standard after decades of development. The acceleration sensor convert the received acceleration signal into an electrical signal and transmit it to the data acquisition system. Selecting sensor require considering sensitivity, frequency, range, and test environment. CMFD is difficult for shaft because they are often used with gearbox or bearing, making it difficult to pinpoint the source of fault. CMFD based on vibration signal theory, algorithm, and experience are mature, but have flaw. Installing redundant sensor to capture vibration signal increase cost and take up space. The vibration signal can only be measured at one point. Comprehensive, systematic, integrated, and interactive systems are difficult to form. Information flow is the transmission of mechanical failure information to the top signal and electrical signal along with energy flow. In addition to mechanical vibration, nonlinear change in parameter such as acoustic emission and temperature can be used for fault diagnosis.
Hello, my name is MOHD AZRIE. Next is fast Fourier transform or FFT and wavelet transform. Nowadays, most modern signal processors uses FFT which converts time domain frequency to frequency domain signal to analyze fault characteristics. FFT is replaced by wavelet transform. Wavelet transform is built based on short-time Fourier transform localization to produce a changing time frequency data. Wavelet transform is ideal for time frequency signal analysis as it can show a problem by transformation, localizes time frequency analysis, and refine the signal using scaling translation. It can adapt to time frequency signal analysis. However, it is not suitable for monitoring that involves variable speed and load. In this slide, this is a diagram of causal chain and monitoring components for wind turbine. The vibration monitoring is on generator, gearbox, shaft, pitch, and yaw. The vibration monitoring has wide application but needs the installation of various redundant sensors. It needs to follow standards, and the process of incorporating vibration monitoring into the components is intrusive. For conclusion, wind turbine is a mechanical machine that needs constant monitoring to ensure that it operates in the most efficient manner. In the shaft of wind turbine, it is monitored using vibration signals that can indicate faults in the operation of the shaft. Torque measurement is also viable as it shows if any imbalance is happening in the shaft. However, vibration measuring is costly to incorporate into machines as it is an intrusive process and involves the installation of redundant sensors that must be up to local set standards.